let me zoom around here a little bit. This is
So,
you realize, of course, that we are recording here.
my methods were admittedly questionable in determining the volume because I projected the graph onto the cardboard and then assumed that that was perfect. However, it's pretty close to perfect. It's only 8%.
Now you're not assuming. You never assume that the real world is a perfect image of the mathematics, or vice versa. You're assuming it's pretty close. You are not assuming it's perfect.
So I didn't compute the length of my squares. I just used my ruler to measure them based on my graph. So anyway,
yeah, of course, yeah.
And this was a real devil to make. Anyway,
good one.
I used square cross sections, and there we go.
Yeah. So what did you give the volumes in both cases? Yeah.
All right. The volume in cubic centimeters is 1 meter, and actually that's not right. The volume in cubic centimeters is 1710.
1710. How many cubic centimeters in a cubic meter?
10,000.
Ah, good.
That's my problem.
Yeah.
Anyway, and then the other thing is the actual amount should be about 633 cubic units. And 1 cubic unit is about 2.5 cubic centimeters in the model that I am using.
Okay.
So,
yeah.
There you have it.
Okay, very good. Okay, looks like Lucas here.
Boy.
Yeah.
Okay, so I have y squared equals x as my function. And I use squares. And so I was using width, so my delta x was 3/16 of an inch. And my scale is just that 1 unit on the actual graph, so 1 unit of the x value is 1 inch. So pretty simple, and that's
cleverly planned.
So it's in both directions, which allows me a pretty simple conversion there.
Yeah.
I decided to do a left-handed Riemann sum because it's easier to see the parabola under it.
Yeah.
So which actually fails a lot of it takes away accuracy though, because had it been a right-handed Riemann sum, I would have only been off by about 4%. But with the left-handed Riemann sum, I am off by a whopping 16%. So I ended up calculating the integral. I got 22.81 square inches, or inches cubed. And when I did it just with the measurements that I had taken, we got 19.14 cubic inches.
Okay.
So I think that is attributed to my choice of left-handed Riemann sum to better visualize the parabola under it.
Yeah.
Nevertheless, I was very content with my work.
I think you have every right to be. Could have done a midpoint Riemann sum for that matter.
I could have.
Yeah.
But I didn't.
Anyone else spent a lot of time worrying about left and right? I would assume that most of you would just have come as close as you could. Okay, and try to get it up there. So the concern about the rectangle approximation method seems very sensible. I think this is Julian here.
Yeah.
Okay, good.
Okay, so this is the graph of y equals secant of x from y equals 1 to 5. And using the approximation, I got 86.96 inches cubed. And for the, actually no, that's for the integral. For the approximation, it's 91.00 inches cubed. And for the integral, it's 86.96 inches cubed. And that is a 4.6% error.
Yeah, very nice. Okay, now, I think I'm going to come over here to get Stephen.
4.7. Can you see this?
Yeah.
So, my function was y equals x times sine of x. And my window, I chose from x equals negative 3.25 to 0, and that should be the same thing as from 0 to 3.25 because it's volume and the graph is symmetrical. But I just chose to start from the left to the right, and I also chose left-hand Riemann sum, and I think that goes with choosing the left-hand side to a model. And so I use semicircles with a delta x of 0.25, and in effect, the left-hand Riemann sum ended up not being very far off because of the symmetrical continuous function, because for whatever I overestimated on the left-hand side, or whatever I overestimated on the left-hand side, I underestimated on the right-hand side. So it balanced out. So for my estimated Riemann sum, I got 55 point. Oh, and I also used the scale of 2 inches for every 1 unit. Did I leave anything else? Oh, okay. And then I got 55.5784 inches cubed for my estimated. And then I got 55.1248 inches cubed for my analytical, and that gives me a percent error of 0.8229%.
Yeah, that's remarkable, and it's. I think you're right. It's that's a ridiculously good percent error. You very cleverly had the some of your errors canceling out other errors. Yeah. But no, nice. Okay, if you could slide back, I think I can get Tricia. Yeah, that's it. It's interesting watching the facial recognition thing on this. In a lot of cases, it jumps from face to face, which is interesting to watch on this end. Most of you have more experience with these cameras than I do. I've had various video cameras, but they're always, next generation's always different. Yeah, go ahead. Yeah.
So,
come on.
The graph I did, or the function I did, was y equals the arctan of x. From x equals negative 3.5 to 3.5, and my cross sections were squares, and the total of my Riemann sum, so the all of these volumes added up, was 5,037.8275 centimeters cubed, and but the integral was 5,021.3271 centimeters cubed. So that gave me a 3.159% error.
Well, looks real good. It seems if it might really be that accurate. That's a lot of squares there. If we can have people slide over a little bit, I can get Elizabeth and then Hannah. Okay. Go.
Okay, so this is y equals sine x over x, and on the interval from x equals negative 2 pi to 2 pi. And yeah, so my the value for the integral I got was 2.98 about, and for the model it was about 2.79 or 2.80. This is in units, not centimeters cubed.
Units. How does your unit compare to centimeters, or did you even go there?
Well, 1 centimeter cubed is equal to pi over 845.
There you go. Yeah.
So,
yeah.
So there's that.
Yeah. That got some very clever ways of dealing with the units problem. I like it. Yeah. That's, okay. Great. And
she didn't want to do any unnecessary math.
you mean she didn't want to do any unnecessary arithmetic, for which I applaud her. Yes, arithmetic belongs in a completely different course, physics or statistics or something. This is a math course, and what people mean when they say do the math is do the arithmetic. which,
Drum roll, please.
yeah.
Alright, so I did the function y equals 0.
I can't, the people looking at the video will not be able to see it.
It was a joke. I actually didn't do y equals 0.
You did, oh, I see. Joke, okay. There's the model. There.
Okay, so I did y equals sine of x from negative pi to pi with square cross sections. So my computed value was adding up all these square-like figures. Was approximately 7,292 centimeters cubed, and then my analytical value was 6,770 centimeters cubed, so I got a 7.71% error.
Yeah, that's really pretty good.
Yeah.
Okay, good. Not quite 100%, what, he's off someplace, is he? Yeah.
Yeah, Pranav skips whenever he can.
Yeah, does he? Okay.
Yeah.
Yeah, that's good to know. Okay, that's